Today we are discussing the polymers, natural and synthetic rubbers. Rubber is a material that is obtained from a rubber plant having the scientific name Hevea brasiliensis. 72 production of rubber is in Thailand, so we can say that highest production in the world of rubber is in Thailand, although other countries like Brazil also produce a good amount of rubber. Rubber is a polymer having the monomer isoprene. Isoprene is basically 2-methyl buta-1,3-diene, and the important thing is natural rubber has all cis configuration. Isoprene has 4 carbons. It is buta-1,3-diene. We can write it like this: 2-methyl. Now complete the bonds. It is CH2 double bond. This is also CH2. This is CH. So we can say that the N moles of isoprene or 2-methyl buta-1,3-diene, they polymerize to form a polymer. Now when the polymer is formed, one can think of the shifting of the bonds. This bond will shift here and this bond will combine with the next butadiene molecule, and similarly this CH2 will combine with the butadiene on this side. So we can write the polymeric structure as CH2. Here it binds with another molecule on the other side, CH3. A new double bond is formed here, CH, CH2 and N times. So this is the polymer, that is rubber. Now how it is having cis configuration. So here it goes, it is CH2, it is combined with carbon. This carbon is also attached to CH3, double bond, carbon. Now there are two groups attached to this carbon. Now you have to decide to have cis configuration. What do we need at this position? ਇੱਥੇ ਸਾਡੇ ਕੋਲ ਕੀ ਹੋਣਾ ਚਾਹੀਦਾ? Out of now there are two groups attached to this carbon. What are they? Hydrogen and CH2, which is continued further. The hydrogen te CH2 ਦੇ ਵਿੱਚੋਂ which one has higher priority? Obviously CH2 has higher priority, and here this CH2 has higher priority. So we will write the CH2 group on this side and a hydrogen here. So this is one monomeric unit. Now what will be the second part? Isoprene. Second isoprene unit will be connected like this: CH2, C, CH3, double bond, C, CH2. The chain is continuous on this side, and hydrogen. ਤਾਂ ਹੁਣ ਅਸੀਂ ਇੱਥੇ ਨੋਟ ਕਰ ਰਹੇ ਹਾਂ, if you look at the configurations, that we have a cis configuration at this bond, a cis configuration at this bond, and for that matter all the bonds coming on this side, all the bonds on this side, all are cis configured. Synthetic rubber is prepared by free radical polymerization. If we polymerize isoprene in laboratory using free radical polymerization, what is the structure of the polymer obtained? Let us see: CH2, C, CH3, double bond carbon. Now in this case the thing to remember is that all this is having trans configuration. Now a फर्क है natural rubber ਦੇ ਨਾਲੋਂ. So this is also an important question: what is the difference between natural and synthetic rubber in terms of configuration? So this is the CH2 group, it is continuous on the other side, and then we have S side te aayega CH2, so that makes it trans. Hydrogen is on this side. High priority groups, this is a high priority group, this is a high priority group, they are on opposite sides, so configuration is trans. Now connect the other unit. We have here CH2 connected to a carbon. Now CH3 will come on this side, double bond C. Next again we have to decide CH2 and H. CH2 इस साइड पे आएगा तो हाइड्रोजन इस साइड पे आएगा, and then again CH2 is connected to CH2 of the next carbon, H, double bond C, and so on and so forth. So if we look at the structure now, it is trans at this position, it is trans at this position, it is trans at this position as the structure is continuous. So we can write synthetic rubber is having all trans configuration. So this is also known as synthetic rubber, has its name, that is called gatta parcha. Now there is a history to rubber, how it became popular across the world. It was Charles Goodyear. Two persons are given credit for the evolution of the tire industry. One is Charles Goodyear and Dunlop. Yeah, we will talk about Charles Goodyear, who is credited with the technique of vulcanization. Charles Goodyear ने अपनी सारी ज़िंदगी गरीबी दे विच कड्ढी. He was an inventor of those times and of course born in 1800, and it was around 1840s he developed the process of vulcanization. ਚਾਰਲਸ ਗੁਡੀਅਰ ਨੇ ਰਬੜ ਦੇ ਬਣਾਏ ਹੋਏ ਬੈਗਸ ਪੋਸਟ ਆਫਿਸ ਨੂੰ ਦਿੱਤੇ, ਬਟ ਲੇਟਰ ਔਨ ਇਟ ਵਾਸ ਫਾਊਂਡ ਕਿ ਉਹ ਜਿਹੜੇ ਬੈਗ ਨੇ ਉਹ ਗਰਮੀ ਦੇ ਵਿੱਚ ਮੈਲਟ ਕਰ ਗਏ. ਚਾਰਲਸ ਗੁਡੀਅਰ ਨੇ ਟੈਕਨੀਕਸ ਡਿਵੈਲਪ ਕੀਤੀਆਂ. ਉਹਨੇ ਮੈਗਨੀਸ਼ੀਆ ਹੀਟ ਕੀਤਾ ਰਬੜ ਦੇ ਨਾਲ, ਅਤੇ ਉਹਨੇ ਆਪਣੇ ਘਰ ਦੇ ਵਿੱਚ ਰਬੜ ਦੇ ਬੂਟ ਬਣਾ ਕੇ ਰੱਖੇ, ਪਰ ਜਿੱਦਾਂ ਗਰਮੀਆਂ ਆਈਆਂ ਉਹ ਬੂਟ ਮੈਲਟ ਕਰ ਗਏ. ਤਾਂ ਉੱਥੋਂ ਚਾਰਲਸ ਨੂੰ ਲੱਗਿਆ ਕਿ ਇਹਨੂੰ ਕਾਫੀ ਜ਼ਿਆਦਾ ਇੰਪਰੂਵ ਕਰਨਾ ਪਏਗਾ ਇਸ ਪ੍ਰੋਸੈਸ ਨੂੰ. ਅਤੇ ਉਹ ਚਾਰਲਸ ਗੁਡੀਅਰ ਸਾਰੀ ਉਮਰ ਜਿਹੜਾ ਉਹ ਇਨਵੈਂਸ਼ਨ ਤਾਂ ਕਰਦਾ ਰਿਹਾ, ਲੇਕਿਨ ਉਸਨੇ ਕਿਉਂਕਿ ਉਹਦੇ 'ਤੇ ਬਹੁਤ ਜ਼ਿਆਦਾ ਕਰਜ਼ਾ ਵੀ ਸੀ, ਅਤੇ ਉਹ ਕਈ ਵਾਰੀ ਇੱਕ ਦੋ ਵਾਰੀ ਉਸ ਨੂੰ ਜੇਲ੍ਹ ਦੇ ਵਿੱਚ ਵੀ ਜਾਣਾ ਪਿਆ ਇਸ ਸਿਲਸਿਲੇ ਦੇ ਵਿੱਚ, ਅਤੇ ਉਹਦੇ ਦੋਸਤਾਂ ਨੇ ਕਈ ਵਾਰੀ ਉਹਦੀ ਹੈਲਪ ਵੀ ਕੀਤੀ. ਤਾਂ ਉਹਨੇ ਇੱਕ ਟੈਕਨੀਕ ਡਿਵੈਲਪ ਕੀਤੀ ਕਿ ਜੇ ਰਬੜ ਨੂੰ ਸਲਫਰ ਦੇ ਨਾਲ ਹੀਟ ਕਰ ਦਈਏ ਤਾਂ ਇੱਕ ਇੱਦਾਂ ਦਾ ਰਬੜ ਬਣਦਾ ਵਿਚ ਇਜ਼ ਵੈਦਰ ਪ੍ਰੂਫ. ਵੈਦਰ ਪ੍ਰੂਫ ਮੀਨਸ ਉਹਦੇ 'ਤੇ ਸਮਰਸ ਅਤੇ ਵਿੰਟਰਸ ਦਾ ਫਰਕ ਨਹੀਂ ਪੈਂਦਾ. ਇਟ ਇਜ਼ ਵੈਦਰ ਪ੍ਰੂਫ, ਵਿੰਟਰ ਪ੍ਰੂਫ ਔਰ ਸਮਰ ਪ੍ਰੂਫ, ਈਵਨ ਇਟ ਇਜ਼ ਵਾਟਰ ਪ੍ਰੂਫ. ਉਹਦੇ 'ਤੇ ਔਰਗੈਨਿਕ ਸੋਲਵੈਂਟਸ ਦਾ ਵੀ ਕੋਈ ਅਸਰ ਨਹੀਂ ਪੈਂਦਾ. ਚਾਰਲਸ ਗੁਡੀਅਰ ਨੇ ਵਲਕਨਾਈਜੇਸ਼ਨ ਦੇ ਨਾਲ ਰਬੜ ਦੀ ਉਹ ਪ੍ਰੋਪਰਟੀ ਇੰਪਰੂਵ ਕੀਤੀ ਕਿ ਉਹ ਹੀਟ ਦੇ ਨਾਲ ਜਿਹੜੀ ਹੈ ਉਹ ਮੈਲਟ ਨਾ ਕਰੇ, ਅਤੇ ਬਹੁਤ ਜ਼ਿਆਦਾ ਟੈਂਪਰੇਚਰ ਲੋ ਹੋਣ ਦੇ ਨਾਲ ਉਹ ਬ੍ਰਿਟਲ ਨਾ ਹੋਵੇ. ਤਾਂ ਉਹ ਜਦੋਂ ਵਲਕਨਾਈਜੇਸ਼ਨ ਦਾ ਪ੍ਰੋਸੈਸ ਡਿਵੈਲਪ ਹੋਇਆ, ਹਾਲਾਂਕਿ ਚਾਰਲਸ ਨੂੰ ਆਪਣੀ ਜ਼ਿੰਦਗੀ ਦੇ ਵਿੱਚ ਉਹਦਾ ਬਹੁਤਾ ਕ੍ਰੈਡਿਟ ਨਹੀਂ ਮਿਲਿਆ, ਹਾਲਾਂਕਿ ਪੇਟੈਂਟ ਵਲਕਨਾਈਜੇਸ਼ਨ ਦਾ ਚਾਰਲਸ ਗੁਡੀਅਰ ਦੇ ਨਾਂ 'ਤੇ ਹੋਇਆ. ਔਰ ਜਦੋਂ ਇਹ ਗੁਡੀਅਰ ਟਾਇਰ ਕੰਪਨੀ ਸ਼ੁਰੂ ਹੁੰਦੀ ਹੈ 1898 ਦੇ ਵਿੱਚ, ਤਾਂ ਉਹਨਾਂ ਨੇ ਇਹਦਾ ਨਾਂ ਜਿਹੜਾ ਕੰਪਨੀ ਦਾ ਉਹ ਗੁਡੀਅਰ ਨੂੰ ਡੈਡੀਕੇਟ ਕੀਤਾ ਉਸ ਦੀ ਕੰਟਰੀਬਿਊਸ਼ਨ ਕਰਕੇ. ਤਾਂ ਇੱਥੇ ਇਹ ਵੀ ਜ਼ਿਕਰ ਕਰਨਾ ਬਣਦਾ ਹੈ ਕਿ ਜਿਹੜਾ ਸ਼ਬਦ ਵਲਕਨਾਈਜੇਸ਼ਨ ਹੈ, ਵਲਕਨਾਈਜੇਸ਼ਨ ਸ਼ਬਦ ਹੈ ਜਿਹੜਾ ਇਹ ਵਲਕੈਨ ਤੋਂ ਆਇਆ. ਵਾਟ ਇਜ਼ ਦ ਮੀਨਿੰਗ ਆਫ ਵਲਕੈਨ? ਵਲਕੈਨ ਇਜ਼ ਰੋਮਨ ਗੋਡ ਆਫ ਫਾਇਰ. ਤਾਂ ਅਸਲ ਦੇ ਵਿੱਚ ਤਾਂ ਰਬੜ ਨੂੰ ਸਲਫਰ ਦੇ ਨਾਲ ਹੀਟ ਕਰਕੇ ਅਤੇ ਫਿਰ ਉਸ ਤੋਂ ਬਾਅਦ ਵਲਕਨਾਈਜ਼ਡ ਰਬੜ ਬਣਦਾ ਸੀਗਾ. ਲੈਟ ਅਸ ਲੁੱਕ ਐਟ ਦਾ ਪ੍ਰੋਸੈਸ ਆਫ ਵਲਕਨਾਈਜੇਸ਼ਨ, ਹਾਊ ਇਟ ਇਜ਼ ਡਨ. ਸੋ ਰਬੜ ਵਾਜ਼ ਬੇਸਿਕਲੀ ਹੀਟਡ ਵਿਦ, you have a raw rubber with you, Raw rubber is heated with sulfur at a temperature of 373 to 415 Kelvin when we get vulcanized rubber. हालांकि ਇਹਦੇ ਵਿੱਚ ਇੱਕ ਦਿੱਕਤ ਸੀਗੀ ਕਿ you have to heat it for long time. Long heating had to be done and then you get vulcanized rubber. So what is the structure of vulcanized rubber? If we write the polymeric structure of rubber, it was like this. We have CH2, C, CH3, double bond, CH, CH2, then again a CH2 of the next unit, then C, CH3, double bond, CH, CH2, and S. We have drawn two isoprene units here. Similarly, draw another chain in the same pattern. This is first isoprene unit. Now we are writing the second isoprene unit. So after heating with sulfur, cross links were formed at allylic positions. Now what are the allylic positions? This is an allylic position, this is an allylic position, this is allylic, and this is allylic position. So we can show one cross link like this, that we remove one hydrogen from here. Let us remove hydrogen from here and hydrogen atom from here. This is, and connect them by a sulfur atom. So let us draw this. This is a sulfur cross link. Similarly, it may be here that we connect it another allylic carbon. Let us say this is allylic carbon, connect them with sulfur, and a important चीज है कि it can be any number of carbons that are combining across the allylic position. For example, we may remove an hydrogen from here and a hydrogen from here and just connect them with a number of carbon atoms in between, sulfur, sulfur, sulfur. So different number of carbons may be combining. ਤਾਂ ਇਹ ਸਲਫਰ ਕਿੰਨਾ ਪਾਇਆ, ਕਿੰਨਾ ਕੰਟਰੋਲ ਕੀਤਾ, ਉਹਦੇ ਨਾਲ ਅਸੀਂ ਰਬੜ ਦੀਆਂ ਪ੍ਰੋਪਰਟੀਜ਼ ਨੂੰ ਜਾਂ ਅਲੱਗ-ਅਲੱਗ ਕੁਆਲਿਟੀ ਦੀਆਂ ਰਬੜਸ ਪ੍ਰੋਡਿਊਸ ਕਰ ਸਕਦੇ ਹਾਂ. ਬਟ ਦਿਸ ਪ੍ਰੋਸੈਸ ਵਾਜ਼ ਵੈਰੀ ਸਲੋ ਐਜ਼ ਡਿਸਕਸਡ ਕਿ ਸਲਫਰ ਦੇ ਨਾਲ ਲੌਂਗ ਟਾਈਮ 'ਤੇ ਹੀਟਿੰਗ ਕਰਨੀ, ਤਾਂ ਉਹਦੇ ਲਈ ਫਿਰ ਬਾਅਦ ਦੇ ਵਿੱਚੋਂ ਨਵੇਂ ਸਬਸਟੈਂਸਸ ਯੂਜ਼ ਹੋਏ ਵਿਚ ਵਰ ਕਾਲਡ promoters or activators, which will activate the vulcanization. So here we will discuss two activators. One is mercaptobenzothiazole, mercaptobenzothiazole. So what is the structure of mercaptobenzothiazole? It is also known as MBT by the people who are involved in vulcanization process. There is a benzene ring and thiazole. Thia means sulfur, azo means nitrogen. So we have a ring which has nitrogen as well as sulfur connected by a carbon, a double bond, and SH. So mercaptans are compounds having SH group. So this is mercaptobenzothiazole. More so we can call it 2-mercaptobenzothiazole. Another substance that was used as an activator was a dimer of this. We can make the dimer like this: sulfur, sulfur, then again another thiazole ring, and benzene ring. This compound is known as 2,2 dithiobis benzothiazole. Bis means twice. Benzothiazole. So these two compounds were used to accelerate the process of vulcanization. So with this the rubber would become hard, it will not melt, and in winters it will not become brittle. So that revolutionized the tire industry, and moreover a number of rubber products were available in the market. Now we will have a look at different type of synthetic rubbers that have come up now, which have properties similar to the natural rubber, and one such substance is called polybutadiene. Polybutadiene is, we have buta-1,3-diene. This is the monomer. N moles of this, after doing using Ziegler metacatalyst, we get a polymer. The structure of the polymer is CH2 So this substance has properties nearly close to that of the natural rubber. So what has happened here is during polymerization process, this CH2 will bind with the other butadiene on this side, and hence this double bond shifts here. This double bond will bind with the carbon coming from the next butadiene group. So this is formed what we call at polybutadiene, and more so this will be called cis 1,4 polybutadiene. Bu for butadiene, Na for sodium, and S means styrene. What is styrene? When phenyl group is attached to vinyl group, it is called styrene. So styrene is it is the addition polymer that will be formed. Styrene is reacted with butadiene, as the name suggests. Now, in the presence of organic peroxide, now we can think of कि एज डी बॉन्ड है इतने शिफ्ट हो जाएगी, it will combine with this carbon, this double bond shifts here, and this double bond will combine with another molecule, CH2CH C6H5. CH will combine with CH2 group, CH. Now the double bond is at this position, CH, CH2, and this is N times. So this rubber is known as SBR, or styrene butadiene rubber. Next, similar to this is Buna-N, or nitrile rubber. As in previous case it was styrene, now instead of C6H5 we have a CN group here. So this nitrogen actually refers to nitrile. So this gives us the idea that acrylonitrile is one of the monomers. Bu means butadiene, so it combines with butadiene molecules. So a large number of such molecules may combine to give us a monomer. As discussed in the previous case, now what is going to happen? This double bond will be shifted, pi bond will make a sigma bond at this position, this double bond will shift here, this pi bond will shift here, this pi bond will shift here, and form a sigma bond with the next compound. So we have CH2CN, CH2, then again CH. Now there is a double bond at this position, CH, CH2, and N times. So here Na means sodium. So as is obvious, when you do its polymerization, again it is free radical polymerization, or in the presence of organic peroxide, the polymer formed will be CH2CCl double bond CH, CH2, N times. Now as before, this pi bond has shifted here, this pi bond will shift here, and this will bind with one molecule on this side and with another on this side. Now